this is the presentation of my cs50 AI traffic project. We've been assigned to create a convolutional model which would infer the images with the and find the traffic lights, traffic signs on them, and take the categories for them, which traffic sign is on the picture. And here's the TensorFlow model that I have written. It has two initial sets of the convolutional and pooling layers. So each set, as you can see here, each set consists of one convolutional 2D layer and one max pooling 2D layer. Both pool sizes consist of the. I'm gonna just launch this program, and meanwhile, while it loads, I'm gonna explain more. So both pool sizes are 2x2 grids, and the first convolutional 2D layer has 64 components, and this number doubles on the second layer. So after defining two first layers, convolutional layers and the pooling layers, we then flatten them, and here we already have the hidden layers. So both hidden layers have dropout rates in order to not overfit our model on the training data, to generalize them, and both of those models have the activation function which is called celu. So this is a bit different than what Mr. Brian used in the lecture. The relu function was used in the used for the handwriting digit recognition, and I experimented a little bit, and I used this function, and which turns out behaves better for this kind of images. So yep, that's the difference. And finally, yes, this first component has 512 components, and which is split in half in the second hidden layer. And finally, we have the layer with the number of categories of 43. That's the number of how many types of traffic signs we have in this project. So yeah, finally we compile this model and we return it from this function. And here's the statistics. The model has already started to train, and this model performs reasonably well in the beginning, but the change in accuracy slows a bit after 6th, 7th epoch, as you can see, and there's definitely a bit. You have to choose what you want to lower the training time or to increase the accuracy. So there have been some models with higher accuracy which take much more time than to be trained on in this process of experimentation. And this one has been the one that has the least training data compared to the accuracy. So it actually it behaves a bit different on each time you train it. Sometimes the accuracy is 94%, sometimes 92%. Now it's 89%, and yeah, you can see the loss that is 0.37. And that's basically all from my presentation. Thank you, whoever watches this.